On these problems on MathXL, they will make you find the positive coterminal angle. Some of their problems are in degrees as well. I can't tell how, like, I look at as many iterations of the problems as I can, but I can't tell if they're gonna really pop one up for you that's degrees. You can always, use your calculator as much as you need to. The nice thing about the calculators now is that you guys, I think, all have the new operating system. And this math has gotten a lot easier in the last couple of years. So remember, you can use your calculator to add those thetas. Just don't put the pi in. Just do, negative pi over 4 plus pi over 3. Not that you guys can't do that. It's just faster to do on a calculator. So to multiply, we're going to multiply our r's, we're going to add our thetas, and then we don't need to simplify. We're just staying in polar form. So leave in polar form, that's just cosines and sines. So I'm going to take here are my r's, I'm going to multiply them. Radical 2 times 10. And then I'm going to add my thetas. Cosine of negative pi over 4 plus pi over 3 plus I sine of negative pi over 4 plus pi over 3. To make it prettier, I would reorder this guy. I would make that 10 radical 2. And then again, I would do this in my calculator. The word in my calculator I would do is this: negative 1/4 plus 1/3. And get pi over 12. You could absolutely find cosine of pi over 12 using, let's see, what did we do to find cosine? For pi over 12, we use difference formula, right? Back in January, remember sum and difference to find 12? Yeah, you don't have to do that. Leave it. Leave it in polar form. Leave it in polar form. All right, to do our division problem, we're going to divide our r's, and order matters here. Order matters here, which is good for this one because then we don't have to rationalize. So our order here is r1. If we're doing z1 divided by z2, then we're going to do radical 2 divided by 10. So we're going to divide our r's, subtract our thetas. So really the thing to be careful about is that order. Order doesn't matter with multiplication and addition. It does matter here with division and subtraction. So we're going to do negative pi over 4 minus pi over 3. And again, in your calculator, you would just do negative 1/4 minus 1/3. Absolutely. So when you do negative 1/4 minus 1/3, I think you get negative 7 pi over 12. Does anybody check my work on that?
Yeah.
Thank you. And this is where I am happy with that. MathXL is going to want you to add 2 pi and get the coterminal angle, the positive coterminal. Again, in your calculator, what you would do there is just do negative 7/12 plus 2 and get the fraction. When we did that by hand, we did 24 pi over 12 because that's 2 pi, right? Anyway. In your calculator, just don't put in the pi's. All right, but for me, on the test, that is a lovely final answer. I'm fine with that. Good so far? Multiply your R's, add your thetas, multiply your R's, subtract your thetas. And this is where we're going to use Demoivre. I don't like.
Demoivre.
Yeah, Demoivre.
Exactly.
Yeah, I don't.
I can't even say it.
Thank you for your support. So this lets us take a power. This is a formula that lets us take a complex number to a power. And it's pretty straightforward. The tough part with these is if you start, like here, no big deal. Here, if you start with a number in standard form, then you're going to have to turn it into polar form. It's going to be your first step on, and these are numbered a little bit different. This is 9 and 10 on your paper. So if you're working ahead, on 9 and 10, the first thing you're going to do is get polar form. And then you can use the theorem. However you would like to pronounce the theorem. So to get this, to do this guy, yes. Yeah, I'm sorry. This one is on your equation sheet. So the way you apply it is you take your R to the power and then you multiply your thetas with that power. R to the power, multiply your thetas with that power. And again, this one is on your equation sheet. And I was just working on your final exam this morning, and there's one like this on your final exam. I was taking problems off of it, so you should say yay. I know that was a sarcastic yay, but I was taking problems off of it. And not adding it. Okay, so we're going to take our R to the power, we're going to multiply our thetas with the power, and then we can just distribute. So this guy, 2 sine of 20 plus I sine of 20. Don't get worked up on this one that you need to get into A plus BI form, because here's the first thing we're going to do is apply that theorem. So it's going to look like this. 2 to the third cosine of 3 times 20 degrees plus I sine of 3 times 20 degrees. So that's how you work that theorem, whether you have degrees or radians. 2 to the third is 8 cosine of 60 I sine of 60. Again, those degrees or radian values, those angle values are always going to match. And now, I know degrees hurts, but degrees isn't so bad in first quadrant. So 60 is the same as pi over 3. Cosine of pi over 3 is 1/2. And here's where do you guys want me to put the I, first or last? First. Okay, I times radical 3 over 2. And so now here, what you would say with your degree values there, or in radians, if you were just asked to find the number in polar form. Now we're going from polar to rectangular. So here, 8 times 1/2 is 4. Eight times I times radical 3 divided, so 8 divided by 2 is 4. That's probably how I would write that. Again, that order, this 4I radical 3 is just a little multiplication problem. So whatever order you want is fine. As long as that I is not under the radical. Go so far? Okay. Start the next one. While I get this one out of the way. Okay, we're taking this one to the 4th power. write it like 4/1. Again, I like to lean into fractions. So if I have radian values, I'm gonna So I'm just applying the theorem there. So I'm taking my r to the power, and then I'm multiplying my thetas with the power. So it's 4 times 5 pi over 16, 4 times. So 4 is my number out here. So this becomes a power on this guy, and it multiplies with these.
Oh,
Yep. So radical 2 to the 4th. 4? Yeah, that's how I did it too. Group them. So there are 4 of them. There's 2. So it's 2 times 2 is 4. Here I like to do this. So 4/16 is going to be a 4 on the bottom. So if we were just asked for polar form, we would leave it here. You need to be careful when you're doing the Math Excel, because they will ask you, like sometimes you will just leave it there, sometimes you will find standard form. So make sure you're reading carefully and not doing too much work. See, I know I need radical 2/2s. And 5 pi over 4 is third quadrant, so everything's going to be negative. I need a negative and a negative. And when I distribute that 4 in, since I'm dividing by 2, you can absolutely do the middle step where you have your fractions there. Oh man. Negative 4i radical 2/2, whatever order you want there. But your 2's are going to cancel. Your 4 divided by 2 is 2. Or 2 radical 2i, however you want to make that okay for your eyeballs. So let's do 1. Let's do 9 real quick. So we have 1 where you've gone from standard form to polar form, and then use your theorem. So for number 9, we're going to start like we started those problems on the front, where we have, okay, so A is 1, B is -1. So we need to, for polar form, we need r and theta. So polar form looks like this. And it is, we are to the 4th power. And then once you get it into polar form, then you can just take it to the 4th power and multiply it. So we have A and B. We want to find r and theta. For r, we use square root of a squared plus b squared. Again, like it's on your equation sheet, so lean on your equation sheet. Know that it's there. So square root of 2, and I'm going to plug it in once I get it. Theta, to find theta, we do arctan of b over a, so -1/1. So I know tangent is 1 at my 4ths. And if my A is positive and my B is negative, that's just like my X being positive and my Y being negative. So we're going to make that either negative pi over 4 or 7 pi over 4. So for these problems, I think it's more work to get it into polar form than it is to actually apply the theorem. Applying the theorem now, you're just going to take your radical 2 to the 4th power and multiply in your 4. Yeah, it is just 7 pi there. Any of our odd pi's, so if it's like 5 pi or 7 pi, where's that going to be? Yeah, all the odd ones. So if you're thinking about your unit circle, all of your odd pi's are at pi. 5 pi, 7 pi, 9 pi, 101 pi. All of your evens are at 2 pi. So if you're doing a problem like this and you're like, 7 pi is just coterminal with pi. So cosine's negative 1, sine is 0, all of that work for negative 4. It makes you mad, like, hey, the answer for 10 is negative 8.